Welcome to this explainer. Today, we're going to explore why mastering your mud transfer system is absolutely critical to preventing catastrophic rig failures. I mean, think about it. This system is literally the circulatory system of your drilling rig. If you spent any time working on a rig or managing oilfield operations, you already know that keeping that drilling fluid moving safely and efficiently is what makes or breaks a job. Because when these systems fail, oh man, everything downstream feels it, and they feel it fast.
Our source material pulls no punches with this quote. The mud tank area is one of the higher risk zones on any rig. And honestly, that right there is exactly why we're here today. Failures in this high-stakes zone don't just cause a minor headache. We're talking direct pipelines to dangerous spills, toxic exposure, and severe environmental violations. So, we're going to focus intensely on how identifying these hazards early, along with nailing down some essential safety protocols, can actually protect your crew.
Just look at the sheer scale of this system. Placing ourselves right in the middle of this complex tank layout really illustrates the immense beast you are responsible for maintaining. We're not just talking about a couple of garden hoses here, we're talking about a massive, integrated network. You've got storage tanks, mixing hoppers, and these insanely high-powered centrifugal pumps that are handling heavy, abrasive, and sometimes highly toxic fluids under immense pressure.
So, here is our roadmap for today. We'll look at 1. Mud transfer system hazards. 2. Essential transfer safety protocols. 3. Overflow and spill prevention. 4. Managing contamination risks. And 5. Identifying equipment failure hazards.
Let's jump right into Section 1, Mud Transfer System Hazards. We're dealing with some baseline hazards here that make rigorous safety protocols totally non-negotiable. Think about toxic hydrogen sulfide gas, H2S, trapped in contaminated returns, or the terrifying high-pressure wellbore control issues caused by routing mud to the exact wrong place during a kick. And let's not forget the physical, everyday dangers. You've got rotating agitators, unguarded pump impellers, and the incredibly severe slip hazards created the second drilling mud spills out onto a metal grating.
Moving on to Section 2, Essential Transfer Safety Protocols.
The crucial takeaway here is that before a single drop of fluid ever moves, you have got to run this pre-transfer checklist. It keeps everyone's cognitive load low and ensures safety isn't just brushed off as an administrative chore. You have to physically walk the line and verify your valve positions. Don't just assume a valve is closed because someone said it was yesterday. Briefing your crew on exactly what the shutdown signal is before you start the pump, that's what keeps a tiny leak from turning into a headline-making spill. Now, for the active transfer execution phase. Grouping these procedures into bite-sized sequential steps is vital. Our sources actually highlight this as your ultimate defense against cavitation and pressure spikes. Step 1, always open that suction valve first. Then start the transfer pump slowly. It really reduces stress on the seals. And make sure you maintain two-person oversight. Having one person managing the controls and another keeping eyes on the receiving tank means you are never flying blind.
All right, Section 3. Overflow and spill prevention.
What's really fascinating here is how modern rigs use overlapping layers of technology to protect the floor. You absolutely shouldn't rely on just one system. It's like a safety net. By combining the simple mechanical reliability of float sensors with the continuous real-time data you get from ultrasonic or radar sensors, you build a fail-safe network. These systems are actually engineered to trigger high-level alarms right around 85 to 90% capacity. That gives your crew the critical buffer time they need to react before a tank totally breaches.
Next up, Section 4, Managing Contamination Risks.
Listen, when you're working with premium synthetic-based mud that can cost anywhere from $500 to $2,000 a barrel, cross-contamination is an unbelievably expensive mistake. But these simple prevention rules can keep you from ruining a massive batch just because someone opened the wrong valve. Color-coding your handles and aggressively flushing shared lines with 1.5 times their internal volume, that guarantees old, incompatible fluid doesn't accidentally get pushed into your active system.
But hey, what happens when the hazard is completely invisible? Let's shift our focus to those hidden internal mechanical failures that aren't immediately obvious to the naked eye. Because believe me, on a drilling rig, what you can't see will absolutely still shut you down.
Which brings us to Section 5. Identifying equipment failure hazards.
When it comes to troubleshooting, crews need to rapidly identify and isolate leaks that create immediate slip hazards, because they often mask much bigger system issues. But notice the difference here between a temporary fix and a permanent repair.
Sure, re-torquing a flange connection might stop a drip for today, but permanently replacing that spiral-wound gasket, that's what guarantees your high-pressure line won't blow out during a critical well control event tomorrow. Now, one of the most surprising hidden hazards we found in the material is cavitation. Ever heard a pump that sounds exactly like a handful of marbles tumbling around inside the casing? That's cavitation. And what's actually happening inside is pretty terrifying. Vapor bubbles are forming in the fluid and violently collapsing against the metal. It physically destroys your impellers from the inside out, and it usually happens simply because your suction lines are too small or partially blocked.
This matrix shows the direct cause and effect of ignoring early pump noise versus having to completely replace a destroyed piece of equipment. The biggest takeaway I want you to have here is this. If you hit that severe stage, do not just swap out the impeller and call it a day. If you don't actually fix the underlying suction conditions that caused the cavitation in the first place, well, you're just going to destroy that brand new impeller you just installed.
And then we have valves. Valves are everywhere in this system, and when they fail, they disrupt everything. They're a silent threat. When a valve gets stuck because heavy solids like barite have packed into it, you completely lose the ability to isolate fluid paths. Suddenly, a totally routine minor leak turns into a full-scale rig shutdown, just because you can't physically stop the flow of mud to safely repair the line.
So, to combat all these escalating hazards, modern rigs are really leaning into automated SCADA systems. These act as the ultimate high-tech safety net. By pulling continuous data straight from tank sensors and flow meters, these automated control panels can detect a dangerous overfill condition and physically shut down the transfer pumps in milliseconds. That's vastly faster than any human operator ever could.
But look, technology alone just isn't enough. You can't completely automate away human responsibility. Assigning direct personal accountability for these daily physical inspections is what catches the silent bleed of rig performance. We all know that when an inspection is everyone's job, it ends up being nobody's job. One person must specifically own this checklist every single shift to ensure strainers are pulled, valves are fully cycled, and the system is actually verified safe.
So, I'm going to leave you with this provocative thought. When was the very last time your crew actually verified the isolation valves on your active pit? Think about that for a second. I hope this explainer helps you bring a culture of deliberate, hyper-focused awareness back to your rig floor today. A well-designed, strictly monitored mud transfer system is absolutely your best defense against catastrophe. Take these protocols back to your team, walk those lines, and stay safe out there.